Hi guys, hope all of us are doing fine. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. I'd like to welcome each and every one of us to our discussion for today. We are going to look at an interesting concept of the concept of integrals, and basically we're going to look at the integrals of rational functions. Now, in our previous discussion, we have looked at different types of numbers. And among them, we talked about the concept of rational numbers. Now, in that particular case, we're going to borrow from that specific discussion and try to express this specific type of functions in terms of rational functions. And of course, that's going to be giving us an idea of how we can find the integrals of such a kind of functions. Now, in this discussion, we're going to look at different methods of trying to find integrals of rational functions, since we're going to come across different categories of these rational functions as we're going to be doing our subsequent videos. Now, in some cases, we're going to be required basically to express these specific functions of integrals for some of the rational functions, which are going to be consisting of what we refer to as a quadratic denominator. And in some cases, we're going to see that basically these specific quadratic denominators are going to be irreducible. Now, one of the methods which we're going to use in trying to evaluate this one is going to be a decomposition of this specific function into its partial fractions. And therefore, we're going to see in some cases, we are going to have what we refer to as an irreducible denominator, where the denominator cannot be expressed in terms of its partial or a decomposition of its partial fractions, and therefore it's going to require us to employ some of the methods which we are going to see working for us. Now, in this particular case, we shall also look at some of the functions which are going to be consisting of repeated factors, especially in their denominators. And this is going to be requiring us to use a variety of methods in trying to find this specific, of course, integrals of a rational function. Now, for us to begin with this, we shall look at the basic concepts which I just mentioning in my opening statement. And this is going to be providing for us a way of understanding this specific aspect of integrals of a rational function. Now, in our previous discussion, I basically hinted that these integrals can be given as antiderivatives. And therefore, in case we need to borrow some of the information from, of course, this kind of calculus that we have done in integral and of course a differential, particularly differential calculus, that it's going to be handy for us. In this case, we are going to see that for the concept of rational numbers, I mentioned that for rational numbers, these are numbers which can be expressed in terms of this specific representation. So we're going to use this initial for q in trying to represent rational numbers. And for rational numbers, these are numbers which can be expressed in terms of numbers, a ratio of numbers which are given in terms of a and b. And we're going to see in this particular case that for this specific expression, b is not equivalent to 0. Now we had just basically done a discussion on this, and I encourage our members to kindly check our description boxes for a link which is going to contain this specific link for the particular video, especially dealing with the different types of numbers and their characteristics. Now, in this specific case, we are going to consider expressing, of course, the integrals of these specific rational functions. Now, apart from numbers, we're going to consider what we refer to as rational functions. And these are going to be basically a ratio of polynomials which can be expressed in terms of a function over q of x, which is a rational function. So this is going to be given in terms of a set of the ratio of two polynomials given in terms of fx and g of x, where fx and g of x as a set of what we refer to as polynomials. And of course, we're going to evaluate the rational, of course, integral of this specific type of functions, which we're going to look at this. Now, for the case point, I'm just going to give an example of this specific, of course, example, whereby we are going to have this, of course, a q of x represented using a specific equation, a specific, of course, a rational function of the form 2 all over the square of x minus 1. and we are required to find the integral of such a kind of a function, and therefore this is going to be appearing in the format of this specific representation for an integral, which we are going to have being expressed as the integral over 2 all over the square of x minus 1 dx. Now this is going to be, of course, one of the ways in which we are going to express this specific aspect of integrals. And in order for us to evaluate such a kind of an integral, which is going to be a combination of such a kind of course, arrangement for the polynomials, which we can give a simple example as such, we are going to be required to express this specific, of course, function in terms of its partial fraction decomposition, which can be given for this particular case for the function of 2 all over the square over x minus 1. So this can be expressed in terms of its partial fraction decomposition in terms of this specific representation. So we shall have this one given in terms of that particular representation, whereby the two basically are going to be forming a product of this specific symbol, of course, a rational function which we have given as such. So in this particular case, then therefore we can evaluate the individual integrals of those two respective functions which I've just given on my right side of the expression. So this implies basically that we can have this one expressed in terms of this specific integral of the, of course, rational function dx for us, which is equivalent to 2 all over x squared minus 1 dx. So this is equivalent to the integral of this particular first part of the partial fraction decomposition, which is 1 all over x minus 1 dx. And then we're going to have plus the integral of this negative value of 1 all over x plus 1 dx given as such. And this can be evaluated by finding the specific, of course, values for those individual integrals, which from previous discussion we said that we can find an integral of a form from the integration rules. We said that we can find an integral of the form of the integral of 1 over u du given in terms of the natural log of u plus c. So therefore we are going to borrow from this specific rule in order for us to evaluate this particular integral, and implying that we're going to have so let's have this specific integral given in this particular format. So we shall have this integral expressed in form of the natural log of x minus 1 plus, so in this case we're going to have a plus negative sign, and therefore this is going to be a minus the natural log of x plus 1, and of course this is going to be given a plus c, which is a constant. And this can be expressed in a form of those specific laws of logarithms which will be expressed. For a minus, we are going to have a division, and therefore this is going to be a natural log of the function of 1 x minus 1 all over x plus 1 given as such. So in case we have a subtraction, we're going to do a division. In case we have an addition, we're going to do a multiplication for this specific function. So basically this is going to be giving us a value of this particular, of course, evaluation, which you are going to find in this particular case. And this is going to be forming a simple way for us in trying to find the integrals of such a kind of a simple rational function. Now in our subsequent videos, we're going to look at different methods which are set, of course, which is going to be requiring us in some cases to split the denominator, and in some areas we're going to see that the denominator basically is going to be irreducible in a way that it can't be expressed in terms of its partial fractions, and there are other methods which we're going to be, of course, trying to use in trying to find solutions to such a kind of rational functions. Now kindly check our description boxes. I'm going to put a link of those particular videos, and they're going to be handy in trying to assist us try to find different strategies of finding integrals of a rational function. So that is it for now, guys. By God bless you. Catch us in our next video.